Hello class, welcome to another lecture on Karnaugh Map or K Map. So far, we have discussed what is a K Map. We have learned about the 2-variable K Map, 3-variable K Map, and even 4-variable K Maps. Occasionally, you get K Maps or you get truth tables with don't care function. And sometimes it is instead of sum of products, you get product of sum pattern. Sometimes you get even odd or even patterns, right? So let us just quickly discuss how to deal with these kind of situation in this class. Don't care conditions occurs when you do not always need all the 2 raised to n input combination in an n variable function in order to get a unique solution. For example, if you can guarantee that certain input combinations never occur, for example, in BCD, that is binary coded decimal, the inputs for 1010 to 1111, that is 10 to 15 in decimal, will never occur. Also, when certain inputs will occur, but we really don't care what the output response will be because it doesn't matter to us, right? So in this scenario, we mark X as the don't care. We mark the don't care output in the truth table or the K map with an X. Don't care conditions can be used to further simplify a Boolean expression, and the beauty with don't care condition is that the X can be taken as 0 or taken as 1. Depends on whichever value of X helps you in minimizing the K map. Now let us look at an example where you are using the don't care conditions. So I am given a truth table, and when the input, this is a 3-variable truth table. So when the input is 0, 1, 1 or 1, 0, 0, I really don't care what the output is. The output is X. It could be 0, it could be 1. So when I populate my K map with these with the minterms for all this response, I just put an X where the don't care condition is, and then I have a look at my K map. If turning either of these X into a 0 or 1 is gonna give me a very simple and unique solution, then I'm gonna go for it. For example, here if you see the figure C, my A, B dash, C dash, I was a don't care condition, and I have changed that to 1, which simplifies my output to be equal to Z, A. However, had this been done in the conventional way, then my output would have been AB plus C. Right? If we just take the figure B and try and simplify the Boolean expression, try and simplify the K map, the output would have been AB plus C, right? So this is how you can use don't care conditions to simplify your Boolean, to simplify your K map further. Now, this is another typical example. Like, for example, I'm just not using the don't care at all. I'm just populating the minterms. So I'm getting a very distinct ones. None of the ones are getting grouped up. However, if you see in the figure below, if there are a few don't care conditions available, then I can simplify my K map much better. Now this is another example where you have a few don't care condition and you are asked to simplify the Boolean expression. So X marked in the truth table are don't care. So I am just taking the minterms, that is the term that are ones, and I'm taking the don't care condition, denoting it with the function d of w, x, y, z, and I'm taking summation of d is 0, 2, and 5. So on 0th position, 2nd position, and 5th position, I have an x. So my entire function becomes summation of small m, that is the minterms, plus summation of the don't care. So if I populate my K map, my map looks like the one in the figure. And now, by changing the x to 1 at, w dash x, y dash z, that x, if it is changed to 1, then I get my function as w dash z plus yz, right? Otherwise, it would have been yz plus w dash x dash and z, right? So this is further simplifying the K-map. So that is the importance of having a don't care condition for simplifying K-map. Now also, so far we've just been dealing with minterms or sum of products. K-maps can also be used to represent product of sum. I have a truth table here. X and Y are my inputs, and I am given the max term for each. So I can use this max term to derive my to populate my K map, and I can simplify the expression. However, the big difference between simplifying a K-map with min-terms and simplifying a K-map with max terms is that in max terms, we group the zeros. In min-terms, in a K-map with min-terms, we were grouping the ones. So far, that's what we have been doing. However, if we are using a product of sum method for simplifying the K-map, we have to group the zeros. So again, here I can take my don't care as 0. Initially, I took the don't care as 1 in the previous example, and I simplified my K-map. Now, if it is a product of sum problem, then I take my don't care as 0 and try and simplify. Rest every previous slide, had you had the same amount of variables, and if you had implemented that, you would have definitely ended up using more logic gates than this. So checkerboard pattern in K-maps is very commonly seen as well. So by checkerboard, I mean solitary ones in alternate squares. So you have a few examples of checkerboard variables in the figure below. So how do you simplify this? So if we go to our previous method of doing this, we'll just end up writing the min terms for all these ones. However, you can use the exclusive or XNOR function to simplify these maps further. Now, this is another example of using checkerboard function, of using a truth table with checkerboard K-map, and we have simplified it using two OR gates. Now we need to remember XOR and XNOR gates are only available with two inputs. For more than two inputs, exclusive OR is used, and it is an odd function. That is, it is equal to 1 if the input variables have an odd number of ones in them. And if an XNOR gate is used, then the input functions the input output is equal to 1 when the input has even number of ones in them. Now, the point to be noted here is that both XOR and XNOR gates are available only as two input logic gates. So, if we have more than two inputs, we need to use multiple gates. Now this is an example of odd and even function with 4 input odd function and 3 input even function. So for even function we have used an XNOR gate, and for odd functions we have used exclusive OR. That is all I have for K-maps. I hope you had a very fruitful session learning with me. If you have any questions or any doubt, just feel free to contact us. Thank you very much.